In part 2 of our geometry basics, we are going to look at some triangle theorems. There are 3 triangle theorems that you need to be aware of for this unit, and that will come into play for all remaining units. Our first triangle theorem is that the sum of all, I'm going to put in here, interior angles, let me be a little bit more specific. The sum of all interior angles of a triangle is 180 degrees. So in this example 3, it says find the missing angle. We've got 82 degrees, 55 degrees, and our question mark, which could be x. If you like to set up a formal equation, you can do 82 plus 55 plus x equals 180. Now, some of you may not need to set up that kind of a formula. That is completely okay. But if this works best for you to have a formal way of doing it, that is completely okay too. You can combine like terms and then subtract from 180, as that is our total. So 180 minus 137 gives us x equals 43 degrees. Now example 4 may be a little bit more complex. See if you can pause this and set up the video and solve for x. Hopefully you took a second to pause it. If not, I'm going to talk through it real quickly. So solving for x, same concept as example 3, A, B, and C. All of these angles are going to add together to be 180 degrees since they are all on the interior. So we've got 3x minus 10. And then we've got x plus 1, so plus x plus 1. And then 2x plus 3 plus 2x plus 3. And since these are all interior angles of our triangle, this equals 180 degrees. So to solve, combine like terms. 3x plus x plus 2x gives us 6x. Negative 10 plus 1 plus 3 gives us negative 6. Add the 6 to the other side, we get 186. And 186 divided by 6 gives us x equals 31. Now there's no degree sign on this one because it's just x and not an angle measure. Looking down at our second triangle theorem, it is the isosceles triangle theorem. And this triangle theorem states that if 2 sides of a triangle are congruent, remember congruent means they are equal, they are the same. And how we show that sides of any polygon are the same is we use a little tick mark. So we could say this side and this side are congruent. All right, those tick marks are how you show that sides are congruent to each other. So if those 2 sides are congruent, then the base angles are also congruent. The base angles are the 2 angles not in between those 2 sides, or they're across from those 2 sides. So this angle and this angle, these would be considered your base angles. And that's how you show that angles are congruent with those little hoop marks. Now the reverse of this is also true. If the base angles are the same, then the side lengths are also the same. So let's look at a couple of examples. Example number 5, solve for x. As you can see, we have our tick marks here. This side and this side are congruent to each other. Now, if it's hard to see which 2 angles are going to be congruent, let me highlight these 2 sides. The base angles are the angles where the 2 sides do not meet. So that's going to be this angle and this angle. So those 2 angles right there are our base angles. They are equal. So if we're solving for x, x equals 70 degrees. Since one angle is 70, the other angle has to be 70 degrees as well. We're going to come back to example 6. See if you can do example 7 on your own. Again, pause this video because I'm about to go over it, but pause it and try this one on your own. So again, you can see that these 2 sides are equal. Now with example 7, it does not even ask us anything about the angles. In fact, that's not where our x values are. It says solve for x. These two tick marks mean these sides are congruent. They are equal to each other. So that means this side right here, 2x minus 5, is going to be equal to 5x plus 16. If sides are equal to each other, you can set them equal to each other. Put an equal sign in between them if you know two sides are congruent to each other. Now it is solving for x, so we want to get our x's to one side. So I'm going to subtract my 2x. Whoops. Subtract the 2x from both sides. So we have negative 5 equals 3x plus 16. Now be careful, that 5 has this negative in front of it. Make sure you bring that down with it. Then I'm going to subtract my 16. That gives negative 5 minus 16 gives us a negative 21 equals 3x. And then we can just divide by 3, and so we get that negative 7 equals x. Again, it is okay that that is a negative sign. All right, now looking at example 6, solving for x. Now if we solve for x here, we got to be a little bit more careful because of the information that has been given to us. This side and this side are congruent to each other. I'm going to highlight these two sides. Now these two sides, if you notice, the base angles are going to be this angle here and this angle here. So because this top angle is 66, that means this bottom angle is also 66 degrees. And if you notice, these two angles are not where our x value is. So 66 and 66 degrees are our base angles, but we are looking for x right here. Now with that value x, we can use the theorem we have above, where all three add up to 180. So x plus 66 plus 66 equals 180. All three interior angles add up to 180 degrees. So then when we combine like terms, we have x plus 132 equals 180. And when we subtract 180 minus 132, we get that x equals 48 degrees. All right, now looking at our last theorem here, exterior angle theorem. This theorem is the measure of each exterior angle. An exterior angle, exterior means outside, so that is dealing with an angle that is outside of the triangle. So in this case is angle 1. Okay, your exterior angle of a triangle equals the sum of the two remote interior angles. Remote interior angles are the two angles of the triangle that are farthest away from angle 1. So that is looking at these two angles right here, angle 2 and angle 3 in our picture. Now, just to see why this makes sense, I'm going to put a little star right here. That green star right there. Angle 1 and that green star form a straight line, and a straight line is 180 degrees. Well, that green star and angles 2 and 3 are all inside of a triangle, which means all of those also add up to 180 degrees. That's why this theorem works, is because that little green angle is almost connecting them in a sense. So in example 8, you see we are solving for angle 1. Angle 1 is the exterior angle. So that means angle 1 is going to equal the two remote interior angles added together. Here are our remote interior angles. So we add them together, 45 plus 75. Not much solving to do here, but angle 1 equals, we add 45 and 75 together and get 120 degrees. Go ahead and see if you can set up and solve for example 9. Pause this and see if you can solve them on your own. So on example 9, you should have known solving for x. I'm going to find my exterior angle first. So as you can see, 3x minus 10 is my exterior angle. So 3x minus 10 equals, and then I'm going to find my 2 remote interior angles. They're going to be on the other side. Here are my remote interior. So I'm going to add my remote interiors together. So we've got my exterior equals my 2 remote interiors added together, and now we are solving for x. So 3x minus 10, adding 25 and 15 is 40. And now we are going to move our like terms. So subtracting our x's from both sides gets us 2x minus 10 equals 40. Adding our 10, 2x equals 50. And then dividing by 2, x equals 25. If you've got any questions on this, please call your teacher over to make sure that you understand.